I have jotted down to introduce that handout, this. I will call this combining functions. Now watch carefully, listen carefully, no graphing. I've named two functions, for example, f of x is equal to this, x squared plus x. G of x, another function, is 2x subtract 10. Oh boy, I'd like to find, here goes, a combination of those two functions. Now when I say combine them, one way I could combine them and ask you would be to find this. Number one, find f plus g of x. That means just add the two functions up. So if they're asking me to combine the two functions and write as f plus g, no problem. Take f, add to it g, combine like terms, and I think I'm going to end up with x squared plus 3x minus 10. I did it quickly. And it looks like if you wish, and most of my students would, you could even factor this. But I would accept x squared plus 3x minus 10, you're done. That's a combination of two functions. Another way I could ask you to combine them is this, f subtract g. That would be x squared plus x, that's f. And we'll subtract, and be careful here, some sign changes will take place. You got that, that's subtracting. And since that's like algebra, let's do it quickly. I think you'll end up with x squared minus x. You guys remind me if I'm wrong here, plus 10. If you do some sign changes and put like terms together, that's the combination. That's no problem. Number 3, how else could I ask you to combine these two? Multiply them together. F times g. And that would be x squared plus x, no problem, times 2x minus 10. That would be another way to combine them, multiply them together. I will expand that out. Looks like it's 2x cubed. On top of the board here, so I watch carefully. Minus 10x squared plus 2x squared. Oh boy, make sure I got all that right. Minus 10x. Let me check since I'm right there on top of the board. 2x cubed, beautiful. 2x squared, got you. Minus 10x squared, got you. Combine like terms, I think we're okay. 2x cubed minus 8x squared, subtract 10x. And you guys are watching carefully, make sure I have all my math done, the signs correct. I think that's it. Is it?
Yeah.
Is that it? Okay. Now you know I can ask you to graph that. That's a polynomial function. We're not going to graph these. And the last combination would be they may ask you to merely express this on the quotient. The product, now find the quotient. You say, Professor, all they're asking you to do now is put this over this. And simplify if you can. I don't see much I can do here. You can write this, which I don't think is going to help much. Take out a 2 on the denominator, and that's all I can do with that. That's called combinations. You combine the functions. Oh, Professor, let's stay in chapter 4. Forget rational functions. Does anyone see a vertical asymptote mentioned here? No. A crossover point mentioned here? No. Nor are you. Now, here's the way I will close down class tonight. Beautiful class tonight, by the way. Got a lot done. Here's the way we're going to close down. Chapter 4 says, hold on. There are other ways to combine those functions besides adding, subtracting, multiplying, dividing. And they've got a notation for you, not a plus sign, not a minus, but They got a notation for it. Number 5, they could ask me to combine them by doing this. They put, looks like a little circle in between. Not a plus sign, not a minus. But they're saying, please, when you see that little circle in between, it should tell you something is happening for those two functions. Do something to them, like I did the other 4, but something different. At first, it means this. It means take f of g of x. That's what the little circle means. Take f of g of x. Now that looks strange, but we'll break it down. G of x, this part, was given to me as, if I look back, 2x subtract 10. They're asking me, please take f of that. That's what it means.
Substitute.
And then to find that, it says go to the f function and put in that blue. Go back to your f function, replace by the blue. You guys, if I go back to my f function and put the blue in, I will have, and help me out here, 2x subtract 10 squared, I think it is. Right here. Plus 2x minus 10. Please tell me, is that what that means? And that's it. Of course, you like to clean it up. So guys, if I clean this thing up, I'm going to end up with 4x squared. I see a minus, my goodness, 40x. Let me mess this up. Plus 100. And of course, still got this on the end to look at. Let me step back and look at it, make sure it looks good. It looks beautiful. Combine like terms. 4x squared minus 38x plus 90?
Yeah.
Wow. I think. And there's your answer. Now, they give a name. The first one I did right here, of course, is addition. I know the name for this. This back here was addition, subtraction, product, quotient. They call this a composite. I'm trying to find the composite between two functions. Okay, letter or number 6. Let me turn it around. With the circle, little circle in between. There's a composite. This time it means g of f of x. Just a little introduction here. G of f of x. That means f of x, which was given to me earlier as x squared plus x. No problem. And then on the outside, of course, I'm taking g of that. And we know what that means. Go to my g function right here and replace. And put in 2 times x squared subtract, or x squared plus x. And then, of course, back on the g function, subtract 10. Guys, I did that quickly. 2x squared plus 2x subtract 10. For goodness sakes, for the sake of time, I'm going to leave it like that. You might be able to pull out a 2 there and do something with it. I'm going to just leave it like that for right now for the sake of time. I'm getting an idea now. Composites, not too hard. Chapter 4 is not going to be that hard. Aiden?
Yeah.
To close down this and show you what else could happen, I realize we're all tired. I could ask, in number 7, I guess it is, what would happen if you did this? They ask you to find G, little circle with itself, G, which means this. These are all called composites. Get you started in, I'll make some help from the students. G of x back here was 2x subtract 10. Put that in right there. G on the outside. Says please go to my g function. Oh, go right back to my g function. and put that red in. So it's 2 times 2x subtract 10. Close that up, subtract 10. I did it quickly, guys. It's 2x, not 2x, 4x. 4x. Looks like subtract 20, subtract 10, I think that's minus 30. And that's my answer. That's G, circle G. If there's no mistake, I did it quickly. Jeez. Now I could do F with F. Same routine. They're all called composites. All called composites. Now I'm gonna close down here shortly. Can anyone tell me, when I see you on Wednesday, what might be the issue with these composites? They're easy right now. These I've done on the board are easy to see what a composite does. Can anyone tell me on Wednesday, I've got to slow down and show you, or ask you something about a composite that I say, oops, I got to slow down a little bit. They're easy, but something might happen. See, hang one up. I could graph these. That's not exactly what I had in mind, but I could graph. Yes. Oh, beautiful. Now, it might result in something where you have to graph and have asymptotes. I mean, wouldn't that be a beautiful exam problem? Form the composite, and the composite comes out to be a rational function. Then you go on the side and graph that rational function for me. That'd be beautiful. That's not what I was worried about, but it could happen. Yes.
Are you gonna have us take one composite function and interact with another composite function?
Oh, I could. Wait, hold on. I'm not going to right now. You're saying, wait, Professor, why'd you do this?
Like f of g plus or
I've used that type for extra credit in the past. F, circle G, circle H. Then I name the functions for you, and you put them all together some way and get an answer. That could happen. Something else though that I gotta be careful with when I do these composites, and someone in this class I know might realize, Professor, you better be careful when you do these. All the answers on the board are correct, but there's a little condition you better be careful. What is that little being careful is? Yes?
Does it have to do with inverse functions?
Well, we're getting into inverse functions a little bit on Wednesday. Getting close.
something to do with derivatives?
Nope, no derivatives. I'm not going to do a derivative in here. Yeah. God.
The order in which you do it
Oh,
matters.
the order does matter. Absolutely, the order matters. But that's not what I had in mind. Okay, I've got time here. I'm not going to do any more. Only these.
If we solve that, can we get extra credit?
No.
Why?
So you're placing G into F. I'm not going to do it tonight. You're placing G into F. Anyone tell me something I had better be careful about on this particular example before I even attempt it? I'm placing G into F, and I see hands going up, and I'm looking for that beautiful answer. Yes? Like what? Placing G into F. What must I be careful with if I want to do that and make sense of it? Hang on, Lisa, hang on. Come on now, somewhat. Look at the functions. Sophia.
G of x cannot equal to 0.
Oops, getting close. Whoa. So you're saying that, Professor, you better be careful about this because you're placing this into this.
Yeah.
You're placing this into this. For the composite. Is there a restriction as I do it? That's what she's right around what I want here. Is there a restriction that I better be careful with as I do it? Robert?
X can equal
Say it again.
X can't equal 4.
X cannot be equal to 4. And you must place it on the side there as you do this. All this is good, but on the side, you've got to show someone, this will not work if you let X be 4. What would happen if I let X be 4? The G function collapses. And you would have nothing to put in. It's undefined. That could happen.
I have a question.
Lisa,
So if we put in the f function the g, also should the g of f should be swept up. So x minus 4 over x.
no, I'm looking at it in one order. I don't want you to turn this around. My example, I just want this order. I just want to go back to G circle it.
But I was thinking we should be also change and the
No.
should be no.
Not unless you turn it around. I didn't turn it around. Guys, I will see you
Testing.
Wednesday at 4 o'clock. Mr. Parks will send the answers out to the